Hi everyone. This portion is probably going to be the most complicated and most confusing part for everyone. And we've come thus far, so I congratulate everyone and I encourage everyone to press on with this section of sizing up the hull. And we're going to solve multiple variables with multiple simultaneous equations using the basic algebra method of elimination and substitution in this portion. And I'm going to use question 2, as you can see I've already gotten ready. The first two parts, A and B, this is probably something that you could do on your own. And I'm just going to give the final answer written here. And I'm just going to focus on 2C for this example in this lecture. So for part A, the expected time is required in days. So for the oil, I hope you can get the calculations correct. It should be 1634 days. And then for gas, it is 858 days. And for the part B, shuttle tanker comes for offloading once every 12 days. So there's no speed and distance given. It has already calculated for us 12 days when the FPSO storage is full. So we just need to use 12 days and factor into the total production and then apply the safety factor. And the answer for cargo volume with the safety factor of a 10% safety margin, which you have to assume, will be 127,120 meter cube. So these are the three numerical answers, and let me just focus on part C, which is basically solving the multiple variables using multiple simultaneous equations. Alright, so I'm going to go slowly, part by part. So I'm given block coefficient of barge CB equals to 0.95. I hope you still remember what is a block coefficient. L over B as 4.8, B over D as 1.8, T over D as 0.6, and C over V as 0.6. Of course, V, L, B, D, T, they're all given on top. Alright, so let's look at the cargo volume over the underwater volume. So we are given C over V and 0.6. So that translates to the underwater volume being C over 0.6, and this gives me 127 divided by 0.6, and I have 211,870 meter cube. So I've solved one of them, 211,870 meter cube, because I've got the numbers ready. Next, we look at block coefficient. So given block coefficient is 0.95, and we also know that the block coefficient is basically the ratio of the underwater volume over the length, breadth, and draft of a vessel, and this is equals to 0.95. And if we rearrange the whole equation, we have length, breadth, draft equals to V over 0.95, and if I were to work everything out, I would then get LBT is equals to 223,018. Call this equation 1. Okay, so I have the first equation. Okay, next I'm going to use all the parametric equations given over here. L over B, B over D, T over D. these three equations and rearrange. And I'll try to see whether I can substitute out some of them. And in this case, you can observe there's D here, which I can substitute out from B over D and T over D, which I can substitute out. So I need to do a little bit of pattern recognition. Okay, so anyway, let's look at B over D. B over D is equals to 1.8. Rearranging it, I have D equals to B over 1.8. I call this equation number 2. And for T over D equals 0.6. I'm rearranging it with D as the subject matter. I have T over 0.6. Call it equation 3. So what do you see? Equation 2 is equals to equation 3. So equating both of them, 2 into 3, I eliminate D straight away. I would have B over 1.8 equals to T over 0.6. And rearranging it in terms of T, I'll explain why I want to rearrange in terms of T, because I basically want to substitute B into the equation. So rearranging it, T is equals to 0.6 over 1.8 B. That gives me B over 3, and I call it equation 4. Okay. So for this bit, I hope you guys can understand how I get 1 over 3. Okay, it's a simple math which we need to manipulate a bit. Okay. So next, we still have one more expression, which is L over B. So L over B is equals to 4.8. And arranging it in terms of B, I have L equals to 4.8 B, so called equation 5. So if you can see here, I have equation 4, equation 5, I have equation 1. So basically I substitute 5 and 4 into 1, I remove L and T, and I'm left with B. So I'll solve for B first. So let's do this. So substitute 4 and 5 into 1. I will have L is 4.8 B. B remains as B, and then the last bit is B over 3, which is T, is equals to 223,018. So compared with the above, you can see that L, this is L, B remains unchanged as B, and my T is, this is T. So you can see that this is T, and this is L. So this is how I eliminate out L and T. And now I'm going to solve for B. Alright, so let me scroll up. So I multiply everything together. What I get will be 1.6 B cubed equals to 223,018. Solving for B, that would be the cube root 223,018 divided by 1.6. So B is 51.8 meters. And thereafter, I'll substitute 51.8 meters back into equation 5 to find L, into equation 4 to find T, and finally equation 2 or 3 to find D. So let me just do the needful. So L is then equals 4.8b to 51.8 to 48.8, round up to 250 meters. My T is B over 3, which is 51.8 divided by 3. I get 17.3 meters. And my D, B divided by 1.8. So I get 28.8 meters. And of course my V, underwater volume from above, is 211,870 meter cube. Okay, so I've got everything sorted out. Okay, have a good one. Make sure you practice this many times, because this definitely will be accessed and it's not so straightforward. You really need to practice quite a bit to solve this kind of problems. Have a good one.